Okay, this is part 2 of U2A2. And this is just to show if we have covalent structures that they're not all the same. The two big things I want to talk about, and then I'll talk about the outlier. Like we've talked about ionic solids already, right? Those are crystals. Those crystals have pretty high melting points. They're brittle, so if you tap an ionic solid, it can sort of break apart. They are very hard and they are crystals. Right now what we're going to look at are two different types of covalent structures. One is called network covalent, and these are the highest boiling points. These are the hardest. They don't conduct electricity. And the reason that they are so high in boiling point and melting point and why they are so hard is because all they have are covalent bonds. There's no intermolecular forces in between them. They form to make one big structure. There's two big ones I can think of. There's diamond, so that's written as carbon in the form of diamond, so it takes a lot of heat and pressure to form diamond. Another one is silicon dioxide, which is sand. So if you picture those two things, they're very hard, very high boiling point. Now, another type of covalent structure is called molecular. And this is when you get a solid that has forces in between the molecules. So where this is all one big structure, we have one molecule of CO2 here, we have another one of CO2 here. If we cool this, we can get a solid. Okay, so they have very low melting points and boiling points. They are brittle, so if you tap them with a hammer, they will break apart. They do not conduct electricity. So one type of ionic solid, two types of covalent, the covalent and the molecular. One has intermolecular forces in it, one does not. We also have metallic solids, which we have not discussed in high school yet. So this is straight up metals. So for example, lithium, potassium, anything that's on gold, anything that's on the left-hand side of the periodic table. Now, what happens here is metals are positively charged nucleuses with electrons that sort of flow free. Metals don't hold on to their electrons very well. We know this because we look at the electronegativities. Metals are soft. They're malleable, which means we can bend them. They're ductile, we can pull them. They conduct electricity. We know we've got copper wire, it conducts electricity and low melting point. Now you might be confused and you might be thinking, hey, I hit my little brother or sister with a metal pipe and it wasn't very soft. What we're talking about here are pure metals. Pure metals I can bend, I can tear, I do it in the classroom. It's when they're alloys, it's when they're mixed with other things that they get hardened. We can also temper them, or we can use heat to harden up the metals. But ionic, metal and nonmetal, covalent or molecular are two nonmetals, and metallic are just straight metals.